My name is Marlo Hood. Welcome to a new edition of the AFP Foundation's training course for journalists on climate change and sustainable development. The oceans are the lifeblood of the planet. Covering more than 2/3 of its surface, they regulate the weather, the climate, and food cycles. Without them, our orbiting home would be just another barren rock in the universe. The oceans produce the oxygen we breathe and are home for the greatest and smallest of creatures. And yet, our species has treated this vital resource with terrible negligence. We have pillaged its bounty, sometimes to the edge of extinction. We have massively polluted it with oil, chemicals, and trash. And we have changed its very chemical makeup, making it dangerously acidic by pouring CO2 into the atmosphere. Earth's oceans, in fact, are in the eye of a perfect storm of human-induced harms, from climate change, rapacious extraction, and wanton destruction. Let's have a closer look at this grim tableau. About 3.8 billion years ago, the surface of our infant Earth cooled to below water's boiling point, allowing vapor in the atmosphere to condensate for the first time. Over a period of hundreds of millions of years, this caused enough rainfall to fill massive basins on our rocky planet, creating the oceans as we know them. At some point, conditions were right to spawn primitive life, which gradually gave rise to a burgeoning of plant and animal species, first in the water and then on land. Among the more recent of these species to emerge was one, Homo sapiens, that would gain the distinction of being the first to forever change the planet's natural systems, and not for the better. Today, the global ocean covers 71% of Earth and holds 97% of its water. It is divided into 5 main geographic regions, the Pacific, Atlantic, Indian, Arctic, and Southern Oceans, and comprises 99% of all habitable space. It is thought to host millions of species of animals and plants, most of them as yet undiscovered. Over a third of the human population, some 2.4 billion people, live within 100 kilometers of an ocean coastline. The oceans regulate the air we breathe, producing half of the oxygen in Earth's atmosphere. They absorb, year in and year out, about a third of the carbon pollution humans have released by burning coal, oil, and gas for energy since the Industrial Revolution. Warming and cooling much more slowly than land, the oceans also regulate Earth's weather. They soak up most of the heat that penetrates our atmosphere from the sun, helping to distribute it more evenly around the globe through currents which transport water from the equator towards the poles and from the Arctic and Antarctica to the tropics. Without these steady currents, temperatures on Earth would be much more extreme, and far less of its surface would be inhabitable. When water molecules at the surface heat up and evaporate, winds push the airborne humidity trapped in clouds, bringing crucial fresh water to all corners of the globe. Human activity, however, has already started to disrupt all of these most basic and indispensable of ocean functions. Our unrestrained burning of fossil fuels, long buried under land and sea, has contributed to surface water warming by an estimated 0.1 degrees Celsius per decade since 1970. Carbon dioxide stays in the atmosphere for centuries, so oceans will continue to heat up long after humanity stops spewing CO2 into the air. So far, the ocean has absorbed about 90% of the extra heat produced by the rising concentrations of greenhouse gases, making land masses significantly cooler than they would have been otherwise. For that, we should be deeply grateful. But if climate-addled oceans have spared us in one way, they threaten us in another. When water warms, it grows in volume. Over time, that expansion is enough to raise sea levels. Combined with the impacts of melting glaciers, ice sheets, and the polar ice cap, the rising watermark poses a serious threat to hundreds of millions of people on a timescale of several, not dozens, of generations. The result could be mass migration, even war, as entire nations look for higher ground. As we have seen elsewhere, sea levels are threatening the very existence of some small island states, and others that are low-lying and more populous. The impact of climate change on life in the ocean should concern us too. Warming waters can cause species to migrate, or die if they are unable to adapt. Higher CO2 levels have caused the seas to become about 26% more acidic since the onset of the industrial age, and may have already doomed coral reefs to extinction. Half are already dead or dying, and the rest could disappear by mid-century. While these unique ecosystems cover less than 0.1% of the ocean, half the area of France, they are home to about a quarter of ocean species, including fish critical for human diets and livelihoods. Besides coral, the ocean's changing chemistry is attacking calcium-building animals ranging from microorganisms at the bottom of the food chain to shellfish. Current rates of carbon release into the ocean are 10 times faster than before the last major extinction event some 55 million years ago, and acidification is at its highest rate of increase, according to geological records, in 300 million years. Even if CO2 emissions were to stop, recovery to pre-industrial pH levels would likely take thousands of years. Also at risk are wetlands that host many species of specially adapted plants and animals. One of the most productive ecosystems on Earth, wetlands serve as speed bumps against storms headed for land. They also store floodwaters and break their flow over floodplains. They regulate water quality by filtering fertilizer pollution and provide the ideal environment for the cultivation of rice, a staple for more than half of the world's human population. But oceans are advancing so fast that they can drown wetlands, which are also being usurped for residential and commercial land. Mangroves, waterlogged forests, which serve many of the same functions as wetlands, have suffered the same fate, shrinking in Asia and Africa by at least a fifth in 25 years. Oceans contain the smallest of known species, plankton, as well as the largest, the blue whale. Like land plants, phytoplankton, commonly known as microalgae, convert sunlight into carbohydrates and CO2 into oxygen. They break down and consume dead plants and animal material. When they die, phytoplankton sink and carry the carbon trapped inside them to the sea floor, out of harm's way. These tiny creatures are the biological foundation of all ocean life and make up the lowest rung of the food ladder, rising all the way up to large fish and top predators. Fish, in turn, provide the single largest source of protein for humans. But humans have thrown this carefully balanced ecosystem, evolved over millions of years, deeply out of kilter. Nearly a third of fish stocks today are overexploited, and 61% is fished to the absolute limit of sustainability. Many experts, by the way, believe these UN numbers are vastly underestimated. Populations of fish species consumed or otherwise exploited by humans have fallen by half, and almost a third of all seagrasses have been lost. There's no mystery as to how this happened. Mankind's ability to locate and catch fish has increased by leaps and bounds with the advent of sophisticated tracking and capture technologies. Longline fishing uses lines with hundreds, even thousands of baited hooks to capture tuna, swordfish, and halibut. The lines can be left dangling in the ocean for hours, even days, entangling unintended bycatch such as seabirds, turtles, and sharks. Net trawling, too, has become a more lethally efficient method of fishing. A few decades ago, it was almost impossible to fish deeper than 500 meters, but now bottom trawling at 2,000 meters is a standard practice, with devastating consequences for ocean floor ecosystems. Other destructive fishing methods include squirting cyanide into water to stun and capture fish, or exploding dynamite and scooping up the dead fish floating to the surface. As if all this wasn't bad enough, humans are massively polluting the oceans with chemical runoff from farming and industry, and devastating oil spills from mining and shipping mishaps. Oxygen-depleted dead zones in the ocean are growing as a result. Each year, 3 times as much rubbish is dumped in the oceans as the weight of fish caught. There are an estimated 5 trillion plastic pieces weighing over 250,000 tons in the ocean. Scientists say most seabirds consume plastic at some point, mistaking brightly colored fragments such as bottle tops for food. The impact can be lethal over time. Conservation group WWF estimated in 2015 that the ocean represents an asset worth more than $24 trillion, including the value of fisheries, tourism, and the coastal protection, shipping lanes, and crucial carbon dioxide absorption. If it were a country, the goods and services provided by oceans would make it the 7th largest economy in the world. About 660 million jobs globally depend on marine ecosystems, and about 850 million people, more than 1 in 10, rely directly on coral reefs alone for their livelihood. Humans have always been drawn to the vastness, majesty, and drama of the oceans, with the result that about 80% of tourism, a multi-billion-dollar industry, is based near the sea. But instead of cherishing its many charms, tourism actively destroys them. Beaches and mangroves are cleared for hotel space, divers break off corals as souvenirs, and cruise ships dump garbage and untreated sewage into the water. Healthy oceans are critical to the preservation of life as we know it. Yet only 3.4% of their surface area is protected, and of that, only a portion is effectively managed. An estimated 95% of this vast world, bustling with creatures as yet unseen by the human eye, remains unexplored, and many fear the damage may be far worse than we know. To learn more about oceans, we spoke to an expert. Here's what he had to say.
The oceans are really part of the climate system. So the oceans take up a lot of heat, they move heat around, they're the source of all the rainfall on land. So the way the oceans are impacted by climate change is really important to everyone, not just the growing coastal populations, but everyone on this planet.
Can the oceans still recover from what we've been putting them through? And is there a point of no return?
We are really irrevocably changing the oceans already. One of the consequences of climate change is that about a third of the carbon that we put into the atmosphere every year ends up in the ocean. So that's good actually, because it reduces the amount of change in the atmosphere that we feel, the amount of heating and warming that we feel. On the other hand, that carbon, the capacity of the ocean to absorb that carbon seems to be slowing down a little bit. Particularly through the changes in the biological processes in the ocean. And also that's making the oceans a lot more acidic, just out of simple chemistry. You put dissolved carbon into a liquid, it becomes more acidic. And so becoming more acidic is really dangerous to corals, it's really dangerous to other animals. So your question is about the point of no return, and the answer is really we don't know what that point of no return is. We know that the oceans are changing, they'll be changing for a long time because of all the carbon we put into the atmosphere. One of the things we have to look at really is how we can reduce other human pressures on the ocean to allow ecosystems to adapt to these climate changes that we're putting in, and to really understand a little more, and that's the role of ocean science, is to try to understand the system better and make that information useful for making decisions about managing the ocean.
And what can we as humans do to lessen our impact on the oceans?
Well, so as I mentioned, there's lots of ways we impact the ocean. So, part of that is reducing our carbon footprint. That's really going to help reduce the ocean, reduce some of the dangers back from the ocean as well, reduce the amount of sea level rise. And then the other areas are, being careful about fishing pressure, making sure it's sustainable, planning about where we put oil, economic activity in the ocean to make sure that it's not in the most vulnerable ecosystem areas. So there's a lot we can do positively about reducing our impact in the ocean, being careful about waste management on land so that it doesn't arrive into the oceans.
And you and I, the average person, what can we do?
Well, really, carbon footprint is the biggest thing. That's a big thing with the oceans, but also really to, part of getting political action in protecting the oceans is having public feedback to politicians about the importance of this. So educate yourself, get involved, go visit an aquarium. There's lots of educational material and programs, and you can really understand better your impact on the ocean.
And in what way are the impacts that we have on the ocean having an impact back directly on our lives?
So I mentioned climate. So, I mean, there's some really direct impacts at the coast. There's sea level rise, which is growing slowly and we think will be accelerating in the next 100 years. There is, I mean, the ocean creates other dangers, creates other coastal hazards such as storm surges and tsunamis, which we can develop scientific systems to help prepare for. And then, as I mentioned directly, we have a lot of activities, economic activities. More and more people are living at the coast. That coastal population is the fastest growing population on the planet. And so the activities related to the coast, related to fishing, related to tourism, related to even just the way we impact ocean ecosystems can have, in fact, changes on the physical danger we have. If we're destroying mangrove habitats, for example, the coasts behind those mangroves become much more exposed to waves and storm surges.
Just the last thing, can some of this damage still be reversed?
Yeah, absolutely. I mean, nature is resilient, and so if we reduce the pressures on nature, nature will come back and will occupy its full ecosystem functions.
We've been looking at oceans. Here are a few tips that you might want to bear in mind. Number one, as with any part of the environment, in oceans, ecosystems do not exist in isolation. And impact in one particular thing can have a cascading effect. Example, ocean acidification can kill corals. The dying corals can result in loss of fish species, and the loss of fish species can have a direct impact on humans who rely on them for livelihood or for food. Be careful about making direct equations between terrestrial or land environments and the ocean. They're very different places, and sometimes the same elements, whether we're talking about oxygen or carbon dioxide, can react very differently in each one. Oceans also are more three-dimensional in some ways, or at least gravity has less of an impact than it does on land. That also changes the equation. So be careful about making easy connections. Point number three. Oceans are a little bit like outer space. There's just an awful lot we don't know. I can say safely that 5 or 10% of the oceans are explored. There are hundreds of thousands, if not more, species that remain unknown. Most of them are microscopic, but a lot of them are not. New species, flora and fauna in the ocean discovered every day. So, and also in terms of basic mechanisms, there's still a lot that we don't know. Finally, don't forget that oceans are more than fish in the sea. We tend to think of sea mammals and fish first when we think of oceans, but it's a vast repository of life of all forms. And these different life forms interact, so don't forget that we're talking about the whole package here. When it comes to oceans, here are a few points worth retaining. Number one, the oceans affect everything, from the oxygen we breathe, the climate and weather, what we eat, and where we live. Number two, they cover 3/4 of our planet, most of its water, and 99% of all living space on Earth. Number three, long thought to be so vast that we can pollute their waters and extract their resources indefinitely, it is now clear that the oceans are very sensitive to human interference. Number four, the volume of fishing catches are thought to be vastly underestimated. Number five, if it were a country, the ocean would be the 7th largest economy on Earth, providing irreplaceable goods and services. And number six, only 3.4% of the ocean surface area is protected, and only a portion of that effectively controlled.